Welcome to Ask and Learn.
In this problem, we have an electronic device which is on for 5 minutes and off for several hours. We wish to calculate the temperature of the device at the end of the 5-minute operating period if it is first operated without a heatsink and then with a heatsink. So we assume that the device and heatsink are isothermal. The thermal properties of the device and the sink are constant, and heat loss from the device during the on time is disregarded. Now, the specific heat of the device is 850 joules per kg degrees Celsius, and the specific heat of aluminium at room temperature is 902 joule per kg degrees Celsius. So for the first case, without the heatsink, we'll look at the energy balance of the system. The energy in, and we'll take the device to be the system, minus the energy out of the device is equal to the change in the energy of the device, delta E. Now the energy E in is electrical energy. So that's the work done due to the current into the device. So that's WE. And this is equal to a change in internal energy of the device, delta U. Delta U can be written as M into U2 minus U1. The difference in specific internal energies times the mass. Now we can also write this equation as the rate of change, or the rate at which work is done, the rate at which electrical energy is transferred to the device times the total time delta T. And we can write the right-hand side mu2 minus u1 into m as mc into t2 minus t1. So these two equations are equivalent. So that's our energy balance equation for the system. So the first thing we'll do is find the final temperature. So the final temperature we get as follows. We use the energy balance equation and we substitute our values in. So the rate at which, so the power rating essentially of the device is 25 watts, which is 25 joules per second. And we are interested in a time of 5 minutes. So that's 5 times 60 seconds. And this is equal to the mass of the device, 0.02 kg, times the specific heat, 850 joule per kg degrees Celsius, times the temperature change of T2, the unknown final temperature, minus the initial temperature of 25 degrees Celsius. So if we rearrange this equation, we can find the final temperature T2. So the final temperature T2 of the device is 466 degrees Celsius. So this is the temperature of the device after 5 minutes without the heatsink. Now let's do the same for case 2 with a heatsink attached, with the aluminium attached to the device. Now the energy balance equation becomes the electrical energy transfers to the internal energy of the device plus the internal energy of the heatsink. So again, if we write this as, it's not delta, it's WE. We write this as the WDT into the device times the total time of delta T must be equal to MC times the change in temperature of the device plus MC, this is C for the heatsink now, the specific heat, and T2 minus T1, and this is for the heatsink. So the mass of the device times its specific heat times its change in temperature plus the mass of the heatsink times its specific heat times its change in temperature. So if we substitute the temperature of the device heatsink combination, then we get the following. So we substitute our power rating for the device, 25 joules per second. Again, we're interested in a time of 5 minutes, which is 5 times 60 seconds. And this is equal to mass of the device is 0.02. We'll just suppress the units for now. Times C, which is 850 for the device. That's joules per kg degrees Celsius. And the change in temperature is T2 minus 25 degrees. So we wish to find T2 in this case. And that's plus the mass of the heatsink is 0.5 kg. Its specific heat is 902 joule per kg degrees Celsius. And T2, remember T2 here is the combined temperature of the system, the heatsink and the device together. So again, we can rearrange this equation and find the final temperature now of the system. So T2, if we rearrange this, becomes 41 degrees Celsius, and this is with the heatsink.